the first thing that we've seen is how we write scalars. For example, x equals 5. This is scalar. The second thing is how we write vectors. How do we do that? We write x, for example, equals, and then in square bracket, I can write the numbers inside. Most of the time, it's comfortable to write it with commas, for example, 1, 2, 3, but it's not necessary. I can also write it as 1, 2, 3 without the commas inside. Okay, it's the same. Now I want to remind you how we imported file and how we, in general, manage experiments and manage files of MATLAB. So, as you remember, we had this experiment 1 file. What I want to do now is to create a new folder on my computer. Okay, for each experiment I have one. So I write experiment 1. And then inside I copy the Excel file. So I have it here. Okay. Now we want to import it. So I will remind you how we import the file. We go to home. And then here we have the import data. Okay, I press on it. And then I go to the desktop where I kept the Excel file. It's here in experiment 1. I choose it. And then, I hope you remember, I change the output type to column vector. Okay, and here, where it says time and displacement, that's the place where I change the variable names. Okay, so I keep it time and displacement, and I import the data. I press on this little V. I can quit it, and now you can see on the right side that I have 2 vectors, one for time and one for displacement. Now when I wanted to do the fit to this curve, I go here to apps, to curve fitting. I press on that. Here in the X data, I choose the time. And in the Y data, I choose the displacement. Okay, that's a graph we had. As you remember, here we can see the results. That's the fitting coefficients. We talked about it last time, so if you don't remember, you can ask me soon or just see the video again. And we choose polynomial, we choose degree of 2. We get good fitting. Okay, we can see it here in the R square, it's equal 1. And now we want to save it. Okay, are you doing it? Can someone answer whether you do it with me? Because it's very important that you have it now in MATLAB. So I really recommend you to split the screen to half and then to follow what I do. Okay, if you need, I can do it also slower. Did you import the data or you didn't do it? If someone can answer. Yes, no?
No.
Okay, so take a few seconds and do it with me. Okay, again, how we do it. You have the files on your computer. I hope so. If not, I can send it now in the chat. Okay, I'll add it again to the chat.
Good.
Okay, you have it here. So you import the data, you press here, you choose the file from the desktop. You choose column vectors, and then on this little V, you edit. Okay, so please do it. Afterwards, we go to apps. Here we open the curve fitting tool. Okay, it opens. Here on the X data, we choose the time, and in the Y data, we choose the displacement. Okay, so do it for a second. And in polynomial, we choose degree of 2. Okay, is it clear so far? Hopefully.
Yes.
Okay, perfect. So we chose degree of 2, and now we want to save it into the workspace. Okay, so we go to Fit. I'll make it a bit bigger so you can see it. We'll go to Fit, and here we have Save to Workspace. Okay, we click on that. We get this little window. Now what you can see here is that we want to save the Fit to Matlab. Okay, the Fit is the data that you can see here. Okay, the linear model poly 2, that's the Fit. We want to save it to Workspace, and here in this window, I can choose the variable name. Mostly fitted model is too long for me, so I just write F. For me, when I write F, it's clear for me that it's the fitting curve. The second thing is the good of fitness, okay? Now you can choose here, instead of good of fitness, goodness of fit, so, sorry, good of fitness. I write GOF, okay? That's the goodness of fit. And the third one, just leave it out. Okay, it's not important. It's about data, about the CF tool. It's not really important. So I just unmark it. So I have 2 variables that I want to choose. I press OK. And now you can see that I have them here, F and goodness of fit. So I can quit the curve fitting tool. Sometimes we call it just CF tool. Okay, so if you hear CF tool, that's what people mean. So I quit it. I don't want to save it. And now I have the time vector, the displacement vector, the fitting curve, and the goodness of fit. Now I want to save all that data into the experiment file I already made, the experiment folder. So how do you do that? You go to Home, and you press on Save Workspace. When I press on that, you see I get Save As. I choose the name, let's say experiment 1, okay? And the file is .mat. Files which are MAT, it means that it's the workspace variables, okay? And
Where did you press again?
I pressed here on Save to Workspace. You press on Home, you go back to Home, and then Save Workspace. Okay, when I press on that, I get this window. And here I can choose the same folder as my Excel file. So I go to Desktop, Experiment 1, and here I save it as X1. Okay, that's what is comfortable for me. You can choose any name you want. I can also write Workspace. So it's clear for me that this is the Workspace data. I save it. And now you can see in the folder that I have 2 files. The first one is the experiment, the Excel file. And the second one is the Workspace. Okay?
Elio, can you please show how you save the files of F and GOF?
Yes, when we were on the curve fitting tool, okay? When we were here, after you did the fitting, let's do it for a second. X1 is the time, Y is the displacement, poly 2. I go to Fit, and then underneath I have here Save to Workspace. Okay, please do it with me. It's super important that you'll have it. Okay. Because we go further. Okay, then you can save it as F and GOF, which is goodness of fit.
The first one is fitted model is saved for F, and the second one is for GOF?
Yeah, yes.
So the third one is for nothing?
Just leave it out. It's not
okay.
important. Okay. Okay.
Is there a way to change the color or make the lines wider or something?
Okay, let's do all these questions. Like If it's questions about what we've done so far, I'll give some time maybe for questions because we're many people. And then this kind of questions, if it's not something that I showed, I can either show you in the end, and I'll show you it also today, okay? How you change the colors and how you do all this kind of stuff, okay? So don't worry, we'll see it, but this kind of question, let's keep it for the end. Okay, so we had it, and now we have in the same folder those two files. Okay, what we want to do now is first of all to see it. So I can write, for example, F, press enter, and I can see the model that I've done, and I can write GOF, and I can see the goodness of fit. Now, those files are called struct or cfit. Okay, for you, it doesn't make a big difference now, but those kind of files are those kind of variables are variables that can hold variables inside, and I can access them. How do I do that? I write, for example, f.p1. Okay, if I write that and I press enter, I can see the result just for p1. Okay, if you write f.p2, you see the result just for p2. Okay, the same with goodness of fit. I write GOF dot, for example, SSE, and I can see the result for that. Okay, it will be important for us very soon. Okay, that's one thing. Now I remind you how we use script and why it's important. So we go to home, and we press on new script, okay? If you press on that, you see a new file. Now, scripts are very important for us if we want to do several commands at once, okay? We want them to follow one another. For example, when we do plots, okay, when we graph something, I don't want to write every time on the command window plot, and then the title, and then the X label, and then the Y label, okay? We want to do it all at once, and we want that if tomorrow and the day after, we want to come back to it and change the color or change something that we've done, we can do it very easily. We don't need to do it all over again. That's why we use scripts. So how do we do that? You go to home and then new script, okay? It's very important to save them. So if I created a script for experiment 1, I save it in experiment 1. So you can press either Control S or Command S if you have Mac to save them. You go to desktop, and to the same folder of experiment 1, I can write it again, experiment 1. You can see that script files have the ending of M, not MAT, just M. Okay, and I save it. Perfect. So now we have everything we need. So last time we saw how we do plots. Okay, we just write plot, and then time, comma, displacement. Okay. If you go to editor, if you press on that, you have the sign of run. Okay, if I press run, it will run everything I have in the script. Okay, so press run. It will ask you now, do you want to add something in MATLAB? Okay, just press add to path. Okay, it's not very important, just press add to path. Then you can see the graph. Okay, that's a graph for the displacement over time. Okay, does someone have questions?
You mind showing again what you just did with the plot? Like after you save the file?
Yeah, after I wrote the plot, okay, and I saved the script, I just went to editor, you see it here, and then run. okay, when you press run, it runs everything you have in the script, okay?
Yeah, thanks.
You're welcome. Okay, does anyone else have questions, or is it clear so far? I hope it's clear. Okay, what I have on my computer and I want to show you, okay? I go to here, and here I call it Matplotlib. I don't know why. That's something that I created in my computer. Now, those are many commands that I use very often, and sometimes I forget the syntax, or I'm too lazy to do it all over again. So here I have data for the plot. Many times I just go here, I copy it, I paste it here under the plot that I have, see? And now I just fill the data that I need. For example, for the title, I write displacement over time. And here I go for time in seconds and so on. Okay, it's not very important now. Okay, and when I press run, okay, I have a problem here, doesn't matter. I have the plot with all the things that I wanted. Okay, so far was it all clear? Yes?
Yes.
Okay, perfect. So now we keep going.
Could you just show again where you saved the editor file, the script?
The script, I saved it in the same folder where I have my results here in experiment 1. Okay, I save everything that is related to experiment 1. I save it in the same folder. Okay,
It's just that it told me something like, do you want to change your MATLAB folder? Or
yeah,
something like that.
so just click on add to path.
Okay, thanks.
Okay, so click on add to path. Now, the first thing that I want to do in script, because when I open MATLAB, okay, if I quit it and I go again, I won't have my data. Okay, let's see it. I quit it. And now I open it again. All the data that I had in the workspace will be gone. Okay, so we want to load it again. So what we want to do now, you see, it's all gone. So what we want to do, we go to the script that we created and we write load. Okay, now we want to load all the experiment, everything we saved in the workspace. So I go here and I write exactly what is written here. You see, experiment 1, workspace.mat. So I just write it inside the script. So ex1, workspace.mat. Okay, now when I run it, I go to editor and run. I press on add to path again, okay. I have all the workspace, all the data that I had before. Okay, it's all here on the right side. Okay, so we don't need to do the fit every time. We don't need to import everything every time. We just have all the data that we needed so far, okay? So, have you done it all? It's all good?
Last time you
It
used
didn't work.
an apostrophe between the name of the .mat. Is that necessary?
What did I use? Like
An apostrophe,
what is apostrophe, sorry?
like the quotation.
Yeah, yeah. No, it's not very important. Okay. It knows that what you write here is a name. Okay, so you don't need to use it. In the old version, we needed to use it, I think, but now not anymore.
It told me that unrecognized function or variable time.
Maybe you didn't save it in the same name that you wrote, or maybe you didn't write at the end .mat.
I did.
Okay, so we've done that. And now we have the displacement over time, okay? Now what we want to do is to calculate the speed that we had every time, okay? So how do we do that? You remember, wait a second, I'll connect my iPad. Okay, I don't need to connect my iPad. Let's use Lex. Okay. You can see what I opened here, right? On the left. So how do we calculate the speed? We know that the speed, okay, the average speed is delta x to delta t, right? And the speed at every point will be the delta x for every point and divided by the delta t for every point, okay? Is it clear? You know it from math classes or physics classes, right? It's not so complicated also. So how do we do that? Let's say I gave you now an exercise to do it and you have no idea. And you ask a friend and he told you, yeah, just use the diff command. Okay, and you say like, I don't know what diff is. So that's why we have help in MATLAB. Okay, we want to figure out that if we have the displacement vector, let's say the displacement is the vector 1, 2, 3, 4, 5, 6, 7, 8, okay? We want to do this variable minus this one, right? That will be delta x. And then 3 minus 2, and then 4 minus 3. We want to create a vector that of the displacement in the second place minus the displacement in the first place, okay? Is it clear what we want to do?
Yes.
Okay, so
Can
how
you please go over the part once again?
Yes, we want to calculate the velocity, okay? So we need to take, you know what, let's see it on a plot. Time, displacement. Okay? So that's the displacement over time, okay, where the ball was at each time. So how do we calculate now the speed that the ball had, for example, in this point here, between those 2 points? It will be the delta x, which is the difference of where the ball was, to delta t, okay? That's what we want to calculate. So we want to take this dot here minus this dot, okay, for the displacement, divided by the time the ball was here, minus the time that the ball was here, okay? That's how we calculate the speed.
Yes, got it. Thank you.
Okay, so we want to use the diff command. And that's because someone told you, okay, you don't know it by yourself. Someone told you and you want to use it, but you don't know how. So that's why we have the help in MATLAB. Okay, let's go to help. Press on it. Okay, you have it here. If you go to home, you have it here on the right side, this little question mark. So I write help, and then I write here diff, D-I-F-F. See? Now here, you have on the first, a MATLAB command here, okay? You see here that it's a function of MATLAB. So I press on it. Now I opened help in MATLAB, and we saw it last time, and we're gonna see it also today, okay? And we're gonna use it a lot because I want you to be very comfortable with the help in MATLAB. Because when I started to write for you the cheat sheet, I thought like, it's very useless to write it because everything is written here. Everything you need is written here. So now we're gonna go through and see how you use it. So first of all, you have the name of the command. Okay, it's called diff. Now, underneath you have the syntax. The syntax tells you how you write a command, how many inputs you can give and how many outputs you can have, okay? In this case, it doesn't matter how many inputs we have into diff, we get one output, okay? The input variable is a vector or a matrix. We know it because as I write, I took it from MATLAB, when you write uppercase X, it means a vector or a matrix, okay? So now it's a vector, and let's see what it does. In the description, you can see what it does. So read that sentence for a second. Okay, read it yourself. Like, take 2 minutes, try to understand it. Tell me maybe when you're done and you got what it does. Okay? If you didn't get it, let's say you read what is written, but you did not understand what they want, you can go to examples, okay? Now here we have examples. For example, X is the vector 1, 1, 2, 3, 5, 8, 13, 21. And then I write Y equals diff of X. So in the first place, we're gonna have what we have in X on the second place minus what we had in the first place, okay? So 1 minus 1 is 0. The second thing will be the third element in X minus the second element in X. So it's 1, 2 minus 1, and so on. This one is 3 minus 2. This 2 is 5 minus 3. This 3 is 8 minus 5, and so on, okay? That's how we use delta X. So let's write it. So I can write, for example, delta, I write it as D, and then another D for the displacement, okay, equals diff of D, okay? How do you do the difference in time? The same, I write D and then in T, diff of time. Sorry, here I need to write displacement. Okay, that's how I call it. Now, the last thing that we need to do is to divide them, okay? Now I want to show you something which is very important and we need it. So I will connect my iPad for that. Just a second. Will be a short intermezzo. Okay. So in MATLAB or in general from algebra, we know that we can multiply matrices and multiply vectors. Okay. And how do we do that? For example, if I write, if let's say V is the vector A1, A2, A3, and U is the vector B1, B2, B3. Okay, so I can multiply them if I take V dot U transpose, let's say, and then I have A1, A2, A3, and then I have the dot B1, B2, B3. Okay, then I get A1, B1 plus A2, B2 plus A3, B3. I hope you're all familiar with it. Now in MATLAB, many times we don't want to have this kind of matrix multiplications. We want to take the first element and divide it by the first element here, and the second element divided by the second element. So that's why we use the dot sign before the multiplications and division. So if I write V dot multiplication U, then I'm going to have a new vector, okay, just with the multiplication of the elements. For example, A1 dot B1, comma, A2 dot B2, comma, A3 dot B3. Okay, that's how we use this dot in MATLAB. That's how we multiply two vectors element by element. Okay, is it clear or it wasn't so clear?
It's clear.
Yeah.
Okay, so now if we want to calculate the speed at each point, okay, let's go back to MATLAB. So if I want to calculate the speed at each point, I'm going to write that the speed is dt dot, and then this slash dt, okay? That's going to give me the speed of each point. So let's run it and see what I get. Okay, now I get a new vector with the speed at each point. Now pay attention that this vector is a bit shorter, okay? Why? Because we took the difference between two elements. So we have -1 elements. Now it's 99 and not 100, okay? And now when I want to plot it, I cannot plot it normally, okay? Can you think why we cannot plot it normally? What we need to change now?
The length of the time vector.
Exactly, we need to change it. Why? Because we don't have any point in time to any point in V. So we can make it shorter. How do we do that? We can use indexes, okay? So when I have a vector, okay, I can write in rounded brackets which elements I want inside. I can write that I want just one element. That will give me the second element in time. I can also write an array inside. So I can write, for example, 1, 2, 3. For that, I'll get the first 3 elements in time. Okay, you see? I get the first 3. So I want to take all the elements except, let's say, for the last one. Okay, so what I do, I just write time 1, the first one, 2, and that will choose everything, but -1. Okay, then I'm going to get all the elements from the first one to almost the last one, one before the last one. Okay, and then I can plot it. I can plot the time. I have to write here 1, 2, and -1, comma, V. When I press enter, I get it. That's the speed at each point, okay? You can see that it's not very clear, okay? It's not like very straight line, but you can see that it's pretty much straight. Okay, with the fitting tool, we can check how close it is for linear polynomial. Okay, so that's about the speed. Was it clear? Okay, or was it too complicated?
You mind going back to the command window just after you wrote the plot of displacement?
After I wrote what?
Plot of displacement.
Here?
Yeah, so then you had to write experiment 1 and then V?
No, when I press on run, okay, it runs everything I have in the script, okay? So when I press on the script, see it now, when I press run, MATLAB writes me experiment 1. So I will know that it runs everything in experiment 1.
Okay.
Okay. Does someone else have questions or?
Can you explain again the 1 colon and -1 part?
Yes. So if I want to choose just some elements in an array, I write inside, okay, which elements I want. So for example, if I want the first one, I can write just time. And then rounded bracket, I can write the element that I want. For example, it gives me back just the first element in time, which is 0. If I want to choose several elements, I can write, for example, time, and then I write a rounded bracket. And here inside, I want to write an array, okay? For example, I can choose the first element, second, third, and so on, let's say up to 10. Now I'll get back the first 10 elements in time, okay? Now, when I plot time, or let's say the velocity over time, I just want to take 99. So you can choose either to take the first 99 or the last 99. So I choose, for example, to take the first. So I wrote time, and then in square bracket, I create an array which goes from 1 to the last element in time, minus 1, okay? If you remember last time, we saw that we can make an array with jumps, with linear jumps of 1. If we write 1, then colon, to, I don't know, let's say 10, okay, to the last number we want. If I write that, I get an array with all the elements from, all the numbers from 1 to 10 with jump of 1. So here in time, it does the same. I just tell him stop at the end and then take 1 before, okay? Is it clear? If I add in time 100 elements, to write end is like to write time 1 to 100. But because I wrote minus 1, it writes me here 1990. And then I get 99 elements, okay? Okay, so that's how we calculated the speed.
Thank you.
Just a second, please. Okay. Okay, so now let's talk about matrices, okay? So as we have seen before, we can do different, oh, by the way, before I forget, this kind of calculation is called numerical differentiation, okay? It sounds like crazy hard when you hear it for the first time, when you come to the Technion. And as you can see, it's not very hard, right? It's like pretty easy. So sometimes things are not that bad as it sounds like, especially when you use MATLAB, okay? Okay, so let's go further. So last time we've seen that we can multiply matrices, okay? Not last time, like some minutes ago. I'll open again the iPad, okay? And as you can see here, okay, I wrote for you, you also have it in the cheat sheet. What are the differences between the matrix multiplications, okay? So if I have two matrices, A and B, and I want to multiply them, if I write just this little star, it's a normal matrix multiplications, okay, as you can see the result here. I have something else which is called time, and you can see here, pay attention to this little dot, okay? It multiplies the matrix element by element, which means that the first one in A will be multiplied by the first one in B, okay? So I get A times B. Also in the second element and so on, okay? If I do it with two row vectors, it's the same as with matrix. I get the first A1 times B1, and then A3, sorry, it's supposed to be A2, times B2, okay? But if I have a row vector that I multiply it with dot, I write A dot times B, okay? Then I have, you can see here, I have A1. I have this, let's say A twice, okay, here and here. And then times B, here and here, okay? So what I get at the end, in the first place, I get A1 times B1. In the second place, I have A2 times B1, okay? Is it clear how it works? Yes? No? Okay. Okay, that's important. Just remember it. Okay, we'll use it also today a bit. Okay. Now, let's see what we can do with matrices. Okay, matrices are very important, especially in MATLAB. Okay, MATLAB is very good for matrix calculations. And so let's see what we can do. We have some commands. Again, I'm going to open the help because the help is very helpful. If I want, for example, if I have a matrix, okay, let's say A, it equals to 1, 2, 3, 4. Okay, I press enter. I get this matrix A. If I want to find now the, let's say, I want to inverse it. Okay, so I write in help inverse matrix. You see, I have here matrix inverse. I press on that. And here you can see the syntax. How do I write it? And then in the description, you can see what it does. So y equals inv x computes the inverse of squared matrix. So my matrix is squared. I can write, for example, y equals inv a. Okay, as it says in the syntax. I press enter and I get a result. Okay, we can also check it. I can check y times a. And what I'm supposed to get is the, here, is this matrix, okay, the identity matrix, 1, 0, 0, 1, okay? If I want to find eigenvalues and eigenvectors, okay, if you know what it is. If not, it's not very important. Eigenvalues and eigenvectors, okay? Again, I found it in the help. You can see here the syntax, and in the description, you can see what I get back. So if I write E, for example, don't forget that the variable name is not very important, okay? You can choose it as you like. So if I write E equals EIG A, I get a column vectors containing the eigenvalues of squared matrix A. So let's see what we get, okay? I write E equals I A. I get the eigenvalues of A. Okay, I get a column vector with both of the eigenvalues, okay? Does someone have any idea? Does someone have any idea how to separate them? For example, I now want to split it into two variables. One for the first eigenvalue and then the second one for the second eigenvalue. How do I do that? I can use indexes, okay? I can write, for example, EI, E1 equals E, okay? That contains, E contains two eigenvalues, and then in rounded bracket, I can write 1. And E2 equals E2. Okay, and I get the second eigenvalue. Is it clear?
Yes.
Okay.
You mind scrolling up again, now in the command window?
What I wrote here?
Yeah, above it.
Okay, remember that when I look at arrays, okay, each element in the array gets indexed. You see, like you can see it here on the left side. This one will be the first element, and this one will be the second element. and so on. If we have, for example, for the time we had before, I have many elements, okay? So each one gets an index. So now if I want to separate them into different indexes, into different variables, I can write, for example, that the first eigenvalue equals to the first number that I have here in the array. So I write E, and then in round brackets, I write the index. I write just 1. Okay, that's the variable name. I can choose it as I like. And here I can write the array, that's this E, and in rounded bracket, I write the index of the element that I want inside. Okay, the index of the number. Okay.
You mind scrolling up where you define your A metric?
Why define it? Just as an example. I don't need it now.
And then you gave the inverse? No, in your comment.
I just want to show you two things. Some commands we have to matrices and how we find eigenvectors and eigenvalues and everything. And just how you work with the help. Okay, that's the purpose. And now if we want to find the eigenvectors, okay, we can see the second command. Okay, so if I write v, comma d, that's the first time that you see that a command can give us two outputs. Okay, and I write it like that. It's an array. Okay, where for the v we're gonna get the first output, and for d we're gonna get the second output. So if you write it like that, it returns diagonal matrix D, which will go to D, of the eigenvalues, and a matrix V, whose columns are the corresponding right eigenvectors. Okay, so let's see it. If I write now V, comma D, okay, that's how we use commands which can give us two outputs. I write equals EIG of A. Let's see what we get. I press enter, and I get two results. In V, I get the eigenvectors. Okay, those columns. Okay, you can see it here maybe better. Sorry, this one. This is the first eigenvector, and this is the second eigenvector. Okay? This is the first one, as this is the second one. So those are the eigenvectors, and D is the diagonal matrix. And you can see that I have the eigenvalues here inside. Okay? I hope it's all clear, right? Is it okay? Hopefully. Okay, if not, then you have more questions, you can ask me at the end. Okay, I'm here for a longer time, so you have time to ask questions. Okay, now we don't have much more today. Okay, let's go through some more important stuff. Okay, so let's say now, let's clear everything. Okay, from the workspace, from the command window, I write clear all. It deletes everything from the workspace. I can write here CLC, which will delete everything from the command window. Okay, and now I can start like fresh, okay, without anything.
What's the difference between clear and clear all?
Clear won't do anything. After clear, I have to write the variable names. For example, Y, A, time, displacement, okay? This will delete just several variables from the workspace. But if I write clear all, it clears everything I have in workspace.
Okay, thank you.
Now we're gonna go to, let's say, another experiment, and we're gonna use what we've learned so far. Okay, we're gonna use the matrices, we're gonna use the eigenvalues, we're gonna use some things so we can get more feeling of what we're doing. Okay, and at the end, we're gonna learn how to control the plots, okay? And we'll go a bit deeper to the CF tool, not much deeper, but a bit deeper. Okay, so let's say that I have now an experiment, okay? It's called a coupled oscillator. I don't know if you heard it once. For you, it's not very interesting, okay? What you have to know about that, those are two things. First of all, I'll share with you my iPad. So first of all, the metrics which will describe our system is this one, okay? Now, I have here, okay, I'll just tell you so it will be clear. I have here one, let's say one box, which is connected with a spring to a second box. And those one connected with springs to the walls, okay? This one will be K1, and this one will be K2, okay? Now, these metrics describe me the system, okay? That's what it does. And K1 and K2, I give you in numbers, okay? Those are the numbers. So first of all, we want to calculate the eigenvalues, okay? The eigenvalues of A will be omega 1 and omega 2, okay? These are gonna be the eigenvalues of A. And now, afterwards, we're gonna have the displacement over time of, let's say, this box, okay? What you have to do is not very hard, okay? You don't need to know any physics or anything more than just doing all the things that you've learned so far. You have a matrix, which describes your system. You know how to calculate the eigenvalues, as we've seen now. And then we want to make a fit to the experiment that we have. So let's do it now together. Okay, I'm gonna put this picture on my computer, just a second. Of all the things that we need. It's not very hard, okay? Okay. So let's go back now to desktop. Okay. So the first thing we want to do, just a second. Yes. And this one is open here. Okay. So the first thing we want to do is to create a new file, okay, with the new experiment. So I create a new folder. It's called experiment 3. Okay, that's how I call it. I have the displacement over time as I got from the sensor. So I copy it to experiment 3. Okay, I have now the new folder. Now open a new script. Okay, I go to the new script. And I save it in the same folder with the name experiment 3. And I save it. Okay, so do it for a second, and then we're gonna continue. Okay, I'll give you like half a minute to do it. Okay, now when I open a new script, the first, yes?
Can you show it again, how to open a new file?
A new folder on a computer or here? A new script?
Just press the new script?
Yeah, you just press a new script, then you have a new one, okay? And you save it as in the folder of experiment 3.
How do you
so now
save
what I'm gonna do,
script?
What again, sorry?
How do you save a new script?
You just press Control S or Command S okay?
Thank you.
All you have here, see? This little, I don't know you call it in English. Okay, so the first thing that I write in the new script is clear all, CLC, and close all, okay? I want to close everything I had before. I want to clean the workspace. I want to clear the command window. So nothing will, change my results. So I won't have by mistake two variables with the same name, and then I'll start to have some problems. That's how I write all my scripts every time, okay? And many people do it. So do it also, I recommend it highly. Okay, so I'm gonna write first what I checked in the lab, okay, what I got. So I go to the picture, not this one, luckily you. Okay, so I write K1 equals 17.1, K2 equals 15.4. Okay, those are numbers. M equals 0.5. You can do, it doesn't matter if you do space or not, I like it with space, but it doesn't really matter. Okay, then I write my matrix A. A equals 1 over M, okay, rounded bracket, times, now in squared bracket, I write K1, comma, K2, semicolon, K2, comma, K1. Okay, and I write this semicolon at the end. Is it clear why this is the same as matrix A? Okay, you can see that it's the same or not?
Yes.
Okay, so now I want to calculate the eigenvalues for A. So I write omega equals eigen, EIG of A. Okay, in omega, I'm gonna get the eigenvalues. Okay, and I'm gonna run it. I go to editor and run. Okay. So pay attention because we wrote semicolon at the end every time. We have nothing printed under the command window. Okay, and we don't want it. It's very clear from here. Okay, this is the 3.4 and 65. Okay, I'm sorry I confused something. The omega is not exactly the eigenvalues, it's the square root of the eigenvalues. So let's do it. So omega will be the square root of the eigenvalues. I can just write square root and to put it in rounded bracket. Okay, I can write a comment inside another comment. Okay, it's not a problem. And I run it again, and I get here the square root of both. Okay, 1.8 and 8, approximately. Okay, now what I want to do, you remember what I want to do? I want to import the data from the experiment. Okay, so again, we go to home, import data. I go to the desktop, experiment 3, and then experiment 3. I open it. I get again the same window we know with time and displacement. We choose the output type, 2 column vectors, and we import. Okay. So now we have the displacement and time. Now, what we want to do is that we want to make the fit, okay? Now the fit will be this function, okay? It's not a function that MATLAB knows, okay? Let's go to app and curve fitting. Okay, I'll wait a second that you all do it. You know, before we go to the curve fitting, does someone have any question? Or are you good?
No, can you just do it a little bit slower?
Yeah, sure. Did you import the files from experiment 3 to the MATLAB?
Yes.
Okay. So after we imported the data from experiment 3, we go to the curve fitting tool. Okay, we get the data from the experiment, and now we want to make this function. We want to see how we do that. So again, you go to the curve fitting tool. It's inside X. Okay, it's here. I cannot see it well. It's here. Curve fitting. We go to here again. But here, let's choose time for the X data and displacement for the Y data. But here inside, it's not polynomial, it's not Gaussian, it's something that MATLAB doesn't know automatically. So we go to custom equation, okay? Inside here in the custom equation, I can write whatever I want, okay? I can write the equation. Pay attention that the equation that I write is y equals f of x. So it's either I write everything with x or I change it to t because it describes time. And here inside this box, I write the function that I have here. So let's do it together. It's a times sine of omega 1 times t plus sine of omega 2 times t. And then I go out from the rounded bracket and I write exponent times exponent of minus t divided by tau. Okay, now I chose the variables names, okay? You can see it here. I chose it because it's comfortable for me, okay? I didn't have to choose a, tau, omega 1, omega 2. I could choose whatever I want, but it's comfortable for me, okay? So that's how I choose it. Now, did you do it so far? Is it good? Take
Not
like 2
yet.
seconds to copy it and to do it.
Can you show the equation again?
Yes, it's here. Can you see it?
What is tau?
Y tau, that's the name of this little letter. Okay, it's a Greek letter, it's called tau. So that's how I
Yeah.
choose to write it.
I just mean I didn't understand what it means.
Why what? Sorry?
What it means. Like, I didn't see that we explain what it is.
Why is it there? That's a function. Like that's the data that we got from the experiment, and that's the function that describes our results. Okay?
It's just a const?
Yeah, it's a constant.
Oh, okay.
Okay? And just the t, you see x is a function of t. All the rest are just constants. Okay? Now, I have it here and you can see that the MATLAB couldn't work with it. Okay, it wasn't very good. So I can adjust the variables. You see, a equals 26. Tau is something. Omega 1, it thought that it's like 0.9 and omega 2 minus 0.9, which is not the data that I collected. Okay, it's not what I calculated. I know what it approximately has to be. Omega 1 is approximately 1.8 and omega 2 is approximately 8. So I go to the fit options, I click here, and here in the fit options, I can tell him where to start looking, okay? We have here the fit options, and here I tell him where to start looking. So I can write, for example, for omega, I double click it, and I can write 1.8. You see, as I wrote it, MATLAB already started to look at 1.8, and then it could figure out all the rest of the constant that I had, okay, of the coefficients.
Where did you press again?
I press on fit options, okay, and here in the start point, okay, I double click it and I write whatever I want inside, what it's approximately supposed to be. Because when we do experiments, we know approximately what we're supposed to get. So I can help MATLAB, because it's very complicated many times for these kind of equations, to realize what the coefficient is supposed to be. So I help him. I tell him, don't look at 26, start to look at 1 or 8 in this case, okay? So after I've done it, I go to Fit and Save to Workspace. Again, here I change the variable name to F, and here I change it to GOF, goodness of fit. This one I leave out, and I press OK. Now I have it again, I can close it. Okay, did you do it?
Wait, no, can you show again the fit options? What did you change? Because it's not working for me.
Yeah, you can start, you see the start point?
Yes.
So double click on it and write what it's supposed to be. Omega 1 supposed to be 1.8. Omega 2 supposed to be approximately 8. Okay?
Okay, I got it. Thank you.
And then you go
It
to
still
fit.
didn't work for me.
Okay, if it doesn't work, so let's see it at the end, okay? The important thing is that you will get what the fit option does, okay? If not, at the end, I promise it will work for you, okay? I'll see it and we'll talk about that. But just get what the fit option does. Here you have the option to choose starting points, okay, where MATLAB can start looking. So after I saved it to the workspace, you see I have it here, F and GOF. I can quit it. I don't need it anymore. If you want to save it, no, I don't care. And then I can press, because I don't want to save everything now. You remember that for experiment 1, we saved the workspace. I don't want to save all the numbers that I got here. I want to save just the displacement, the fit, the goodness of fit, and the time. So I press them, I right click it, and now I have here Save As. I click on Save As. I go to the desktop, experiment 3, and I check it and I write whatever I want. For example, experiment 3. Again, if you want to save just some variables from the workspace, it's very easy. You just click on them, you choose them together. I do it with Command, but I don't know, I think it's Control maybe in Windows or Shift, I don't know. But I can choose just them, just what I want to save. I right click, go to Save As, go to where I want to save it. In my case, it's experiment 3. I choose the name and I save it, okay? And now I can write here in the script that I wrote, load experiment 3.mat. Now when I run it, I get all the information that I need, okay? See, if I clear all from the workspace, I press run, I get everything I needed. I have the imported data, I have the feed that I've done, all the variables that I calculated here, and I want to keep it, and that's it. Now, okay, the last thing that I wanted to show you, okay, what we didn't see last time, is how we plot the graphs nicely, okay? Now, what I'm going to do, I'm going to write figure, as you remember from last time, just to make some order in the MATLAB code that I write. I'm going to write, hold on, because I want to put 2 plots on the same figure. I'm going to write P1 equals plot of time over displacement. Okay. I'm going to write F1, or let's say plot of the fit. Okay, that's why I call it plot of the fit. I write equal plot of F. For the fit, we don't have to write the X data and the Y data. We just write the function itself. Okay, just draws the function. And now what I'm going to do, you have everything from the, I won't copy, I'll copy it, but I won't change it. It's wasting of time. I want to show you something more important. Okay. And now I can press play. Okay. Now you can see both of the functions collide. Okay. I don't want that. So what I can do is that I can show you now how you have where you have all the properties for the plot. If I write now P1 in the command window and enter, I'll make it bigger, just a second. You can see here all the properties of what I just drew, of the measurements plot. Okay, that's the first one that I've done. That's what P1 describes. See here, right here. P1 is the variable, okay, for time over displacement, for displacement over time plot, okay? And here you see all the properties. Now it looks a bit complicated, but it's not very complicated, okay? I'll show you what I mean. For example, I can choose the color, okay? If I choose, for example, this one in RGB, okay, so I can write P1.color equals, and then I choose 000, it's gonna be black because it's in RGB, okay? I press enter. Sorry, I closed maybe the plot. You have to keep it open. Okay, I write it, and now you can see that it changed from blue to black. Okay, you can see it here. It was blue, but now it's black. I can change, for example, the, where is it? Here, the marker, okay? This is none now, but I can change it to little squares, little circles. So I write P1.marker equals to those little circles. And you can see that it changes, okay? I get both. Now, if you'll see, if you'll go now to the help, okay? It's here. You go to help and you write plot. You have here all the options that you can do to the plots, okay? Just read it. It's very, very, very easy, okay? You can see the plots they make and what they wrote to make it. For example, if I just write plot X, Y, we did many times, you just get a continuous line of the plot. If you write, for example, plot X, Y, 1 and then X, Y, 2, you get two plots in the same figure, okay? If you want to change the color, I'll show you. You go down, more. Here you have the color for the plot, and here you have the RGB triplet. Pay attention that the P1 that I wrote, okay, the plot that I wrote is a struct function, which means a struct variable, which means that I can go to anything which is written here by writing P1 dot the name of it, okay?
What did you write at the beginning of the command window to get all this?
I just write the variable name, just P1 and then enter. And then I can press here on the all properties, and then it opens all the properties of the plot, okay? All the properties I have on the plot. So after I do that, you can go to help, and then in the help you have everything you need. For example, line style, okay? You can see the line style here, and then the result. So I can go, for example, I can write, I'll go to the side, put it next to each other. I can write, for example, P1 dot line style. Okay, you have here the command equals, let's say, those two lines, okay? I want it a dashed line. I press enter, and then it becomes like that, okay? You see that I did a marker and a line, okay? I can disable the line. As you can see here, I can just write none for the line, for example, line style. and then none, okay? Then I will have no line. I'll have just the dots, okay? There you can control everything you want for the plots, okay? From the other hand, I can also control everything I want from the figure. For example, the X limit and the Y limit. How do I do it? I write here, and that's how it is in MATLAB, okay? There is no Y, that's a command. AX equals GCA, sorry. In the GCA now, I'm confused. In the AX variable, if I press enter, the same for the plot, I have everything for the figure. For example, you can see here, if I go to the downer part, xlim. So my figure now goes from 0 to 7. Okay, there it is. I can change it from 1 to 5, let's say. I write AX dot xlim equals 1, 6, 5. When I press enter, see it will change from 1 to 5, okay? Now, we have all the properties, everything you want here, okay? It's all written. You can also see it in the MATLAB help. Like, we don't need to go through everything. There are many things that I don't use, okay? But the main things like xlim, ylim, you have in the help, and I wrote it for you in the cheat sheet, all what I use at least, okay? So, that's how you edit the plot to make it a bit nicer. Okay, that's all for today.
Can you show it one more time?
Yes. Just if someone wants to leave, that's all for today. And from now on, we're going to do questions. So thank you and see you next time.